Hello, we are still in Chapter 5, Section 3. This is Part 2 of this video. We're still in the same process. We're going to still graph another rational function. The rational function is a little different. So let's look at what we got going on here. Analyzing the graph of a rational function. Okay, remember, analyzing just is another fancy way of saying graph the function. And we've gone through the process of I have a coat with holes. The I stands for the intercepts, the horizontal asymptotes and the vertical asymptote is the have. The C in the coat does a cross. Then the oblique asymptote is the OA, and then trace the graph with holes, and those are removable discontinuities. As I've indicated before, the obliques and the holes we don't talk much about. But this case, we got an oblique, okay? So this example right here, you would not see on the test unless, okay, it's a bonus problem. However, okay, that doesn't mean this problem is worthless to everybody who doesn't do bonus. If you don't do a bonus problem, you still need to listen to this video because it still reminds you of other things that you got to do, like the x-intercepts, the vertical asymptotes, and the horizontal, well, we don't have the horizontal asymptote, and the y-intercepts and things of that sort. Okay? So, all right, so let's begin. Look at the solution. So we factor the numerator out, x plus 2, x minus 2 over x, so that's lowest terms. So the domain is all real numbers except for x equals 0, so x cannot be 0. And that means there's a vertical asymptote there. Step 2, we're going to write that in lowest terms. It's there. Okay? Now step 3, because x cannot equal 0, there's no y-intercept. So the graph has two x-intercepts, plus or minus 2, setting the numerator equal to 0, remember. Each have odd multiplicity, so the graph crosses there. Plot the points negative 2, 0, and 2, 0, and the graph will cross the x-axis at both of these points. Okay? And by the way, even though the Kobe rule, we use the Kobe rule to determine whether they cross or they bounce, on rational functions, the vast majority of the problems that you're going to encounter will cross the x-axis. Okay? They can bounce because they could have even degree, okay? But you don't see it very often, but it could happen. All right? Now, next step. All right? The real zeros of the denominator with r in lowest terms is 0, so the graph of the r is a line x equals 0, the y-axis, and the vertical asymptotes are x equals 0 using a dashed line. Okay? So the multiplicity is 0, so is odd, so the graph will approach infinity on one side and negative infinity on the other side. They just described Kobe. Okay? They just described Kobe there. All right? So since the degree of the numerator is 2, and the degree of the denominator is 1, that's when you have the obliques. So guess what? There's no horizontal. Okay? Remember the horizontal, when do they come about? If the degree on top is less, this is definitely not the case, it would be with the y equals 0 or the x-axis. When they have the same degree, do you remember how to do that one? It's the ratio of their leading coefficients. Okay? But in this case, the degree on top is larger than the bottom. So again, you won't have one of this for points on the test other than a bonus. But this is how you find out the oblique. You long divide x in the numerator by the denominator. So x into x squared minus 4, the long division, and the quotient is x. So y equals x is the oblique asymptote. So the asymptote is not horizontal. It's at a line, the line y equals x. So the oblique asymptote is y equals x. And that's what they just showed you there. And you construct that with a dashed line. So to determine whether the graph of r intersects the asymptote y equals x, we'll solve the equation r of x equals x. And so you set that equal to, this is the crossing. So when do we cross the horizontal asymptote? Well, do we cross the oblique asymptote? It works the same way. And we don't, because you set the function equal to x, and you end up with negative 4 equals 0, so it does not cross. That's impossible. So the obliques, the graph stays off of the oblique. So the equation x squared minus 4 over x equals x has no solution, so the graph does not intersect the line y equals x. But it does merge into it. It gets closer and closer. Okay? Step 6, the zeros are of the numerator negative 2 and 2. The zero denominator is 0. Use these values to divide the x-axis into 4 intervals. Okay, this is now, again, they're using the table to test points. So again, step 6, this is something that if you want to pause the video, kind of good to look at what they're going to do. Okay, I'm just saying on the exam, if you try this table thing, you're going to be on this problem for quite a while. So just try to stick with the I have a quote. This just kind of gives you an overview of what the graph is going to look like. So step 7, okay, so we plot the points, so they're going to plot some additional points and what we know. So there's the graph. Now remember the vertical asymptote was x equals 0, and the y equals x is the oblique asymptote. Now look at your x-intercepts. They were 2, 0 and negative 2, 0. I had already found those. Now they found the additional points, negative 1, 3, negative 4, 3, and now you've kind of got the breadcrumbs. You know, you just follow the breadcrumbs around. So there's the breadcrumbs. So because the graph of R is below the x-axis, okay, they're just basically saying this is your breadcrumbs. This is the way you follow the graph around through those points. Okay? And this is basically telling you the Kolbe rule. One side is positive, one side is negative on 0. So that's this slide right here. I will describe this in one word, Kolbe. Basically, they're saying it's positive infinity on one side, negative infinity on the other side. And you know which one based on the x-intercepts. Okay? Now, so notice they had 6 points. There's your graph. There's 6 points there. Okay? Now, look at negative 2, 0. Let's pretend those additional points, negative 1, 3, and negative 4, negative 3 are not on there. Since you know you have to merge into your asymptotes, doesn't the graph kind of have to look like that anyway? So pretend you only had the x-intercepts and you don't have those additional points. Could it be anything else? You got to cross the x-intercepts because of Kolbe. It's positive on one side of the graph, so it's got to be negative on the other side. So you really don't need those additional points. Sure. I mean, I know what you're thinking. You're like, well, yeah, but it does make it easier because I got those extra points, and that way I can kind of get a better feel of what the graph is going to look like. And some people need that visual help, and that's fine, okay? But I'm saying once I had negative 2, 0 and a positive 2, 0, and you have the oblique asymptote in place and you have the vertical asymptote in place, that's really all you should need. But if you need that extra blanket, if you will, then you can actually put those additional points on there. And some people say, well, the more points the better. Well, that's true. But if that's the only problem you get finished with on the test, not so good thing. Okay? So you want to be efficient. You want to be accurate, but you want to be efficient as well. So I don't require all those additional points. So if you look at that graph, if I see that graph without those points that are in the quadrants, I'm fine with it. Okay? So as long as I see that graph, if you want to put those additional points on there, that's fine. Okay? So, all right. So that's our second video. Alrighty. We got one more video on this section, just another example of this one. So, but if there's any questions on this one, you let me know. And as always, have a good day.